Our speakers today, Fredrik, Boulund, and Kretszchmar, have something special planned. They're going to be talking about pair programming and giving a live demo here. So I think this is going to be exciting. So that we can all figure out if pair programming is something that might work for us. If you have any questions for our speakers, you can either unmute yourselves at the end of the talk or the session and ask them directly, or put them into the chat and I'll relay them to them. So without further ado, over to you, Fredrik and Warren.
Great, thanks.
Okay. Well, I was going to give a short introduction to pair programming, but first, I guess we should probably introduce ourselves. So I'm a postdoc here at KI, and I've worked in computational biology since about 2009, and used to do a lot of methods development, and now mostly data science, I guess. And at one point, I worked in industry, so for a short time at a San Francisco startup, and then another company in Oxford. And there, in both places, there was a lot of pair programming going on, and I really enjoyed it. And but since then, I haven't really done much of it. So, Fredrik, how about you?
Yeah, so my background is I have a PhD in what is it really? Like bioinformatics, kind of, from Chalmers. I spent most of my PhD years doing methods development as well, and algorithm development pretty much, for HPC stuff. And I'm currently head of bioinformatics at a research center focusing on microbiome research. That's pretty much it. I haven't really used pair programming that much. Me and Winnie have played around with it a few times before, but that's pretty much it. But I find it quite an interesting technique, and I think it can really, there are some situations where it can absolutely improve the quality of your work. So here we are to try to demo it for you today.
Yeah, okay. So I'll try to give a very brief introduction here. Let's see. Let's go away and right. So we thought the way we see pair programming is basically you get to work together, you get to have fun together, and you might even produce better code. And yes, whether or not that's true is maybe hard to tell, but I'll try to give the case for it, I suppose. Just a bit of history on pair programming. So my understanding is that it comes out of extreme programming, which sort of was invented in the 90s. The idea behind extreme programming is that you take good programming practices and try to do them as extremely as possible. So and pair programming is sort of the most extreme version of code review, basically. So the idea is, if you think of how quickly you iterate your code review, you can go from like a release plan all the way to just sitting in front of your code together. And that's kind of where the idea comes from. And it was, I guess, adopted into sort of the agile movement as part of the through the extreme programming movement. Yeah, and there's been a lot of research on pair programming since the 90s. There are a few papers that are cited a lot from the 90s. One of them is one by Nosek, where they found that teams of experienced programmers completed their tasks 40% faster. And then there's some meta-analyses that we took a look at, and it seems like there's not that much downside to programming, except in certain cases. But how the effectiveness of it sort of depends on context. It depends on how experienced the programmers are and how similar the expertise is between the two programmers pairing, and also on the difficulty of the task that's to be solved. Notably, easy tasks seem to be something where pair programming can lead to worse results. One question that's raised by this paper is it maybe just a form of rubber duck in action? The rubber duck method for debugging is you take a rubber duck and you explain your code to it, and thereby find mistakes. And that also works. And that rubber duck could be the other person, I guess, that's sitting next to you. And then there's another meta-analysis by Komen from 2014, and they argue that it's probably not a good tool to be used all the time. But if you have a particularly difficult problem that you want to solve, or if you're trying to get to a very intense type of collaboration for some other reason, then that might be a good choice to use, or a good method to use. And so there's a few variations on pairing. I think the most common probably is the driver navigator approach. So the idea is you're both sitting at the same screen with 2 keyboards and 2 mice, and one of the programmers is sort of doing the actual programming, that person's the driver, and then you have someone who is the second person is then trying to think more broadly and trying to think about what edge cases are we missing here? Is there a bigger concept that we can maybe think about when we're trying to solve this problem? And the idea is that the driver and the navigator will switch fairly often in their job. Another approach, if you're really into test-driven development, is something called ping pong. And there, the idea is that one person writes a failing test and the other person makes it pass. And then the second person then writes another failing test, and the first person gets to make it pass. And so you go back and forth that way. And yeah, if you're into TDD, I hear ping pong can be a lot of fun. There's a third style called strong style that gets mentioned sometimes that I haven't ever seen in practice, and that is sort of not recommended in most cases by any of the blogs that I've seen writing about it. But the idea is, and in contrast to sort of driver navigator, which is mentioned as traditional here, in driver navigator, you have an idea, and so the idea is, please could you hand me the keyboard so I can type it in. And in the strong style, the idea is, I have an idea. Please take my keyboard so I can tell you what that idea is and how to get it into the computer. And so an idea that you come up with as a programmer never gets programmed by yourself. You have to explain it to the other person. That's the idea. So, but one of the things we can already see here is that even these 2 images of traditional driver navigator pair programming have slightly different views. Sort of in this image, we can see 2 people at the same keyboard equally working on it, whereas on this one, in the traditional view, like one person has the keyboard and the other person doesn't. And that's actually, so I'd say there's a lot of variation how people sort of see or do pairing in practice. So the case for pair programming really boils, and this is from a website that sells a tool for pairing. The way they sort of boil it down is they say that the biggest problem with teams producing code is that as they produce code, the quality of their code tends to go down, and as the quality of the code goes down, the slower it takes to deal with that subpar quality code. And so if you're pair programming while doing this, then you tend to produce better code, even if it takes a bit longer. And therefore, your team as a whole will produce new features at a faster rate for longer on the code base. That's sort of, if you're trying to make a business case for it. Sort of another aspect of looking at it is that, for me personally, actually, when I started programming, I discovered, when I started doing pair programming, it was a completely new experience to me. And I went from thinking of programming as a very solitary thing that we do alone in front of our computers to one that was filled with interacting with other people. And that pairing with people gave me a lot of joy, actually. And so that's you'll be happier. For me, that's really the biggest draw for pair programming. There's some other things that seem to happen is that if you're sitting at a table, okay, interruptions are not an issue for me. I doubt they're a big issue for many people on this call, but if they are an issue for you, then if you have someone else sitting next to you working on the code with you, you're less likely to be interrupted, apparently, at least according to the people who wrote this. And I think that could be true. Then there's this idea of flow, that you're thinking about a problem, and then if you do get interrupted, only one of you two is likely to be interrupted. The other person can continue to think about the problem and bring the other person back into it more quickly once the interruption is over. RSI is a big deal. There are many people who have repetitive stress injuries or who eventually develop repetitive stress injuries from programming. And if you're pair programming, you're only typing half as much, about maybe a little bit more, but about half as much. And less typing is better for RSI. So that's another thing to consider. The other thing that I found with pair programming for me personally also is that once you get used to pairing with other people, you also get more used to asking them for help. I think that's certainly true for me, and I could see that being generally more applicable as well. And then there's sort of different types of pairing. I just wanted to go in that, like, in one company I worked at, there was actually a keyboard and a mouse at two keyboards and two mice at every single workstation. And so if you had a question for someone, they would invite you to sit down and you just start working at the computer and try to figure out what it was that you were trying to get solved. And that seems to be a fairly common recommendation. If you're doing remotely, I've done that as well. I used to use Screen Hero, which is a screen sharing app. And there's sort of this difference between screen showing, which is over Zoom or Skype, where you're just showing people what you're doing. And that's definitely not recommended because it's hard to switch drivers that way, and it's hard to be interactive. There's something called application sharing, which is what we're going to demo today, actually. And it just involves using a code editor online together. And that works quite nicely. But if you want sort of the whole experience of being able to sort of share your whole computer, then there's a tool called Tuple, which we think looks pretty interesting. And the idea is both programmers can interact on one computer together at the same time. This is what Screen Hero used to do. It got bought by Slack and doesn't seem to be available anymore in the same way, but Tuple is an app that promises to do that as well. I haven't tested it. I don't know how good it is. And yeah, so when you're thinking of anti-patterns or challenges with pair programming, there's a few different things to consider, but really there's just one big one, which is disengagement. Don't want that. So both programmers need to be focused on the task at hand. The navigator will maybe think about it in a different way than the driver, but you're really trying to work on it at the same time. And when one of the pair programmers gets disengaged, then the whole endeavor sort of falls apart, and I guess one person's just wasting their time. And as I mentioned earlier, simple tasks can be a bit challenging with pairing, or just maybe not as effective for this exact reason, because it's easier for one of the two people to disengage. Okay, so there's a resource I just wanted to mention as well that, yes, pairing session template I found on the Tuple app. We found on the Tuple app website, and it's a nice little template, a checklist for things to do when you're doing a pairing session. So you start by agreeing on the high-level goal out loud. Then you break the work into a handful of tasks and prioritize them, decide how you're going to switch who's driver and navigator. Then if you care about credit in Git, that's something to configure. And then try to eliminate distractions by turning off your phone. Then work, and then have a little retrospective at the end. So that's all I had to say about introducing pair programming. This is a good time to ask questions before we get into our demo. Does anyone have any questions?
I have a quick one.
Yeah,
that's a really nice intro. Thank you for this. We've been talking a little bit about whether we could use pair programming in hackathons and stuff as a way to sort of help newcomers. But I'm thinking, from watching the last few slides, I'm thinking maybe that's a bad idea to try and pair up more experienced people with lesser experienced people. That the lesser experienced person is just going to get disengaged, like you say. So this is like a method of training at all ever?
I have not. There's probably definitely a gray zone where you've got two experienced programmers and you're trying to transfer knowledge. That's definitely something I've seen it used for. It didn't go into it as much in this session, and that's definitely a selling point for pair programming. I didn't see as much evidence in the research that this is something that happens effectively, but I think if you're careful about it, I mean, I guess in one company I worked in, we definitely used it as a way to make sure that everyone had some knowledge of different parts of the code base. So we'd make sure that we'd rotate pairing. So in that way, you can get people up to speed. I've definitely also seen people with a lot of experience in programming online basically say that if you've got an experienced programmer, that's the real challenge. And what I did see also is there's one blog that recommends that third option, the strong style, as maybe a way to get a novice programmer into something. So the more experienced programmer is the person with, quote, the ideas and tells the novice programmer what to do. I don't know if that works or not. I haven't seen it myself, but that might be one thing to consider.
Thank you.
Just as a side comment on that, I think what we typically see in academia is these kind of workshops where we have an experienced person explaining something to a lot of novices. That's like an even more extreme form of the strong style, where you have a lot of people listening and following along with the instructions, going through things step by step by the instructor. But I'm not entirely convinced that that is actually a very good way of teaching the nuances and the strategy of how you approach and think about the problem. That's mostly about rote learning the basic techniques, I think.
Yeah, it's definitely not. I mean, this data knowledge transfers is something that people hold up as a plus, but I don't think there's as much evidence that pair programming is the best tool for that. Or there doesn't seem to be a clear approach that would be good for that. Yeah. Okay. Any other questions? I guess the other thing I would say is that every place that talks about pair programming and recommends it, or recommends pair programming and writes about it, they all say your first time is going to be challenging. It's definitely a skill to do pair programming. So try it a few times and try to get used to it, and try it with different people as well when you're starting out. That's the other big thing to say here, I suppose. Okay, cool. Then let's get started with our pairing session. So Fredrik and I both like Advent of Code, and we thought we would just do one of the Advent of Code problems. For those of you who don't know, Advent of Code is something that happens every year during Advent, and so December. And you get this website produces or reveals one question to be solved every day. And so you can sort of code along in whatever language you want to. And the coding problems are fairly easy, but they can be really fun to learn maybe a new language or to try pair programming on. Yeah, and we're going to use this online coding tool. It's called replit.com, just because it was the easiest thing. It doesn't require us to have the same environment or tool, or the same coding environment. And since we use very different coding environments, this is a good place to start, or this is going to work for us. Yeah, so Fredrik, do you want to explain
Yeah.
Actually, you haven't seen the problem yet.
No, I haven't. But that's fun. Yeah.
Cool.
Let's go. Yeah. So we randomly picked a problem that looked fun that we haven't solved before. So we're pretty much planning to just go through the checklist that we had there. Sit down, have a look at the problem, decide for a goal, determine a strategy for swapping between driver and navigator roles. And this is like most of these problems are fairly short. I don't know exactly how long this will take, but maybe we'll have the opportunity to swap once or twice.
Can I just a technical question? Can people see my screen? The replit.com webpage.
Yes.
Okay, good.
And we should maybe
Okay.
familiarize everyone with how it works so you can follow along what's going on. So what we
Yeah,
have,
okay.
you explain, Winnie, since you're driving.
All right, I guess I'm driving. Cool, I guess that's been solved. Oh yeah, we're going to, I think we're going to switch every 10 to 15 minutes, so maybe 1 or 2 switches this time around. And the question is a 2-part question. So there, and basically at the end you get, you try to compute a number that you then type into the website, and the website tells you whether the number is correct, and then it'll give you the next question based on the number. We have a main.py here in our files, and it's basically a Python script that we can run with command enter. Come on, yeah, I think that ran, and then it shows up here on the console. So it can be a bit, sometimes things don't quite translate, but let's see if this thing's up and running.
Live demos.
Okay. So, live demos, gotta love live demos.
Yeah.
Yay, hi world 2, and then you can also see that Fredrik has got his cursor there as well. So we can both type into this.
Maybe you should reload the page once, Winnie, because it looks like yours has frozen.
Oh, okay. Let's see here. I'm connected. Yay. Okay. So there's a bit of introduction. There's a bit of a story that goes with each of these questions, but basically this question boils down to your battery is dead. You need to plug it in. There's only one problem. The charging outlet near your seat produces the wrong number of jolts. Always prepared. You make a list of all of the voltage adapters in your bag. So we have these voltage adapters, and you have to, I guess I'll just read. Each of your voltage adapters is rated for a specific output voltage, your puzzle input, which is I put into day 10 over here. And in addition, your device has a built-in voltage adapter rated for 3 jolts higher than the highest rated adapter in your bag. If your adapter list were 3, 9, and 6, your device's built-in adapter would be rated for 12 jolts. Treat the charging outlet near your seat as having effective voltage rating of 0. So since you have some time to kill, you might as well test all of your adapters. Wouldn't want to get... Yes. And so this question boils down to reordering all these adapters. They all are represented by a number. And figuring out what the differences are between them to get from 0 to some max number. So with these adapters here, the highest, the number of jolts you can produce is 19 plus 3, so 19 is the biggest number over here, and then you get put 3 on top to 22 jolts. And there's this aspect that you can only go up by 1 to 3 jolts between adapters. So Fredrik, does that make sense to you?
Yeah, I guess so. I guess the maximum number in that list would be the jolt rating, right? Plus 3.
Yeah, so the maximum is there, but I think you have to make sure that all the numbers are between 1 and 3 away from each other. So if there's a difference of 4 between any 2 numbers, then you, I think, have to stop at that point.
Adapters can connect to a source 1 to 3 jolts lower than its rating. In order to use every adapter, you need to choose them like this. So the outlet has a rating of 0 jolts. So you can only connect 1, 2, 3 rated adapters to that. Of these, you only have only one of these. Only one you have is an adapter rated 1 jolt. From your 1 jolt, yeah, so we're looking at the example here. From your 1 jolt rated adapter, the only choice is your 4 jolt rated adapter, exactly because it has a difference of 3 out of those. And then from the 4 jolt adapter, we have adapters 5, 6, and 7 as valid choices. So we pick the 5 one, so we can not skip any. And then we pick the number 6 and then the number 7. And then from the number 7, we can go to number 10, because that's the difference of 3. And then from 10, we can go to 11 or 12. And then we do the same thing. We optimize to get as many as possible in. So we choose 11 and then 12. And then we have a rating of 15. That's the difference from 3 from 12. and then 16, and then 19. And then the final device is 3 higher than that, which means 22. Okay, what I can try example.
So I'm going to copy this example into a file so we can use it as a test. Woohoo. And I think we have to keep track of, oops. We also need to keep track of the differences that we observe for later.
Yes. I guess for the next follow-up question, I suppose. Or what is the number of 1 jolt differences multiplied by the number of 3 jolt differences? Yes, so you have to keep track of both.
Okay.
Okay.
Since I'm the driver, then I will start programming, I guess. So first thing I thought was to parse the test text file. So we have a parser.
Sounds good.
Yeah. Gosh, it's been a while since I've coded live, forgetting everything.
So while Winnie is starting to code on this, I kind of trust in his ability to code a parser like this. As the navigator, I have the opportunity to start thinking a bit ahead in this problem. So we, when Winnie runs out of ideas, we can see if we can help each other to reach further.
Okay, I'm going to parse these into ints right away.
Fair enough.
And might as well, so does this work?
Syntax.
No! Oh, got it not in. Oops.
Great.
All right, looks like we've got some digits. So what do you think we should do next?
Yeah, how about sorting them?
I think sorting sounds like a great idea. Oops.
Great.
All right.
Excellent. So then I guess we just start. Charging outlet has a rating of 0 joules, right?
Yes, it does. Should we add it to the list?
Sorry?
Should we add it to the list?
Well, it doesn't, yeah, I guess we don't really have to, I suppose.
So what I was thinking is to write a for loop. And then we would just count all the differences. So
yeah,
prev val equals 0, I suppose. So now we can do val minus prev val. And if we have that, then we can just check to see if the difference is bigger than 3, and if it is, then we stop incrementing. And we just report that number.
plus 3 then.
Yeah, let me just check here. All right, that seems reasonable. And then if diff...
But is it reasonable? Because you never update previous value.
Oh no! Well, that's terrible. We should definitely not do that. So yeah, we should definitely update.
It's really weird with this 2 space indent.
Yeah, 2 indentation. Whose idea was that? Okay. All right, so we have to update prev val. Yes. That equals val, right? Oops. Let's see if that looks reasonable.
That looks more reasonable.
All right. Yeah, I've got 1s and 3s.
Yeah, we have a long list that we can use. That's nice.
So I don't think we expect to ever have anything bigger than 3. So I'm just going to raise for now. If that happens. And then what are we supposed to do at the end? Find a chain that uses all of your adapters to connect the charging outlet, blah, blah, blah. Okay, so we have to keep track of tilt differences. So
I guess we'll just keep a counter.
Yeah.
I would use a counter from the collections module.
Ooh, collections. Okay, let's do that. From collections import counter. I always find the counter hard to a bit. Oops.
We could use
counterintuitive,
like a default dict with just an int as well. It doesn't really matter. We prefer that.
Default dicts. I like default dicts. Or self-description.
Lowercase.
Setting corrections? Yes. So diff counts equals default dict. And then I guess is 0 the op?
Put it just an integer there, should be fine.
Ah, right. Okay. Yep, compiles. Great. So
then you can just.
So then we're going to just say diff counts diff plus equals this. Let's see what it says. Diff is not defined. Oh, you're kidding.
Exactly. I think you
have
to first then put it in there.
Oh, dang. Okay, fine.
And I think it should be diff equals that, and then diff counts +1.
Plus equals?
Yeah.
Diff plus equals 1. Like that?
Like that, yes.
Okay, cool. Let's see if this works.
Yeah.
Yeah, looks like we got some numbers. Okay.
And we got 22 1 joule differences, and there should be 10 differences of 3 joules, but we only have 9.
Uh-oh. Oh yeah, we forgot to add the last one. One bigger. So I guess we can just add one to the diff counts at the end. Yeah, because that's the one that you have in your pocket is always 3 joules bigger.
Okay, yeah, okay, great.
So the last one is this here. This adapter's device's built-in voltage adapter would be rated for 19 plus 3, which equals 22 joules. And the highest rated adapter. This is probably going to come to bite us in the second half of this question, but let's just keep it there for now.
Great.
Okay, so the answer, yeah, so let's solve the answer and then we can switch.
Yeah.
What was the question?
The other file then, I guess.
Yeah, number 3 joule differences. Wait, sorry, what is the number of 1 joule differences multiplied by the number of 3 joule differences? Okay. Diff counts 1 times diff counts 3, like that?
I guess so.
They don't say what the answer is, do they? Oh, I guess they just have. Okay, well, let's change the input data. Day 10.
How exciting.
2100. Okay, let's type it into.
Moment of truth.
Yeah. 2200 was it, right? No! Too high. What have I done wrong?
At least they tell us.
It's 2100.
You typed the wrong thing?
Yeah, I typed the wrong thing. But I think we're going to get... I have to wait.
Yeah, I shouldn't brute force the site like that.
Okay. Cool, I guess we could clean up our code a bit while we're at it, while we wait.
I saw a suggestion in the chat that we could skip the read lines because the open is an iterator itself.
Oh yeah, great. Let's do that.
And I guess we could clean up a lot of the debug outputs.
Sure. I think we should be fine without most of this. I kind of want to keep that last debug output.
Yeah.
I think we're going to need that again. And we could probably solve this by... Yeah, so the last diff count could... Oh, no. Now let's keep it this way. Cool. I guess I have another chance now. Let's try this. Yay. Gold star! Woot! Okay. Fantastic. So there were a lot of silver star solutions to this one, so I assume that the next question is super hard.
Yeah.
So,
enjoy live demo.
Yeah.
What is the next question?
So to completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Every arrangement needs to be connected to the charging outlet to your device. The previous rules about when adapters can successfully connect still apply. So the first example above with 16, 10, 15 supports the following arrangements. Oh God, I did not understand what I just read.
Let me see if I can parse this. How many different ways can we arrange the adapters? Every arrangement needs to be connected to the charging outlet to your device. The previous rules about when they can successfully connect still apply. Okay, so it's about finding all the valid permutations.
Oh, like you don't always just, okay, so this one here, 6 is missing, right?
Yeah.
So you could have gone from 5 to 7.
Yeah.
Ah, great. I see a graph coming. Okay, and the charging outlet in your device's built-in adapter are shown in parentheses. Okay, given the adapters from the first example, the total number of arrangements that connect the charging outlet to your device is 8.
Mm-hmm.
Second example has many arrangements. Here are a few. Yay. Oh God, there's 19,000 arrangements. Okay.
Yeah, let's not
Try
print
to remember why you bought so many adapters. Okay. There must be a trillion ways to arrange them. Surely there must be an efficient way to count the arrangements. What is the total number of distinct ways that you can arrange the adapters to connect the charging outlet to your device? Yay. So I guess you're going to be driving now.
Yeah, fun.
Should I actually, I might
maybe just copy the pertinent parts of the example.
I'm going to copy the small part into our README here. And I think that should be enough to keep us.
So how do we best compute these different arrangements?
Well, I'd say we make a graph.
Okay.
And can we do it with dicts of dicts? Does that work?
We could try.
So I kind of just want to import network X. Sorry?
How do you want to construct it? So like for every...
Yeah, so I guess for every number, there's a bunch of other numbers you could go to.
Yeah, right? So like we create a dict that contains all valid options from that position.
Yeah.
Right. Okay.
And then that points to a new dict that then contains all valid options for that position. And then the valid number, and then we just have to count every possible path. Yay.
Mm-hmm. Yay.
I feel like getting it into a dict.
Okay. So, but we already have a dict here, but we could go through the same iterator here, right? Or the same for loop and reuse parts of this.
I think so, yeah.
Yeah. So when we compute the diff here, that's going to be important for our next selection, right? If it's a valid selection.
Yeah. I think we'll want to...
Let's make a tree.
Yeah.
Cool. Let's just make a dict, right? And then we...
I didn't know you could do dict like that. That's cool.
It's the same, just squiggly brackets.
Yeah. Cool. And so then for your add a value,
put the value here, right?
Yeah, and I think so. And then we should be able to
probably use a default dict here as well.
Yeah.
That has a dict inside of it.
I think we also we don't need to keep track of the value itself because that'll be the parent will have that. Yeah. So tree_val. I think we might want to, instead of looking backwards, we might want to look forwards instead.
Yeah.
So we start with 0, and then we look forward in lines, and we find we find the next values that are between 1 and 3 away from the. Yeah, I think that's right. Let's try that.
Okay, and I guess we'll have to compute whether this next value is valid from that value.
Exactly, yeah. I think we were doing a nested for loop here. 2 for loops is probably the way to go. So
yeah, this is going to be very computationally efficient.
God, I hope so.
So we're actually...
We're just we'll do a for loop, but we'll exit out early. As soon as, so I was thinking that the second for loop is for looking at the next 3 numbers to see if any of them are within range.
Okay. So something like 4.
I think we need to enumerate lines.
Yes, so let's do like the index here, and then we enumerate this. And then we can, oops.
I think that the dict definition does still go up. Ah, yeah, never mind. Let's.
But we could compute this first. So for subsequent val in val index 3, something like that.
Yeah, that looks good.
Like that, right?
Yeah.
And then we compute the diff.
Yep.
So that would give us something like this.
So we want to subtract. So we want, instead of val, we want to use subsequent val.
Yes, exactly. Subsequent val.
And then I think we're subtracting val instead of pre-val.
So val. And then if diff is greater than, or actually lower than.
Lower than 4.
We add it into the tree, right?
Yeah.
For value. Subsequent val. Something like that.
I was thinking that the value associated with. All right, so if we assume we're starting at this beginning and the first value is 0, then tree of 0 should be. Oh no, so tree is 4 0. So we'll have 3 vowels for that tree. And each one of those will point to a new dictionary. So I think we need a
like this.
Yeah, subsequent val, exactly.
Val.
Does the default dict create a dictionary there?
Yes.
Cool.
And then
I guess
put here. Nothing.
I think it should be in. Yeah, I think it's another default dict.
Yeah. Okay. You want to see what this looks like, just for a few examples?
Yeah, let's do that. Can you shorten the list to maybe 4 items and then just.
Maybe we can just use the example.
Yeah.
What was the name of that file?
Test.txt.
Okay. So if we just print the tree here.
Yep.
Object not subscriptable.
Val is being. That needs to be lines instead of val for the. Right here.
Oh, sorry. We got a lot of default dicts. And that's an exception, because now.
Oh, we've got some code that probably doesn't make sense.
Yeah.
I think we can delete most of this, and probably let's delete that as well. I think we have to add 0 into the lines at the beginning for this to make sense.
Sure.
Why don't we do that right at the beginning? Is there a prepend for lines, or do we just? I don't even know how you do that in Python, but I guess you could do.
I think it's insert, right? There's an insert method on lines, right? So we could just do lines insert 0 or something like that.
Okay. At 0 0, or does it just do 0
yeah,
default?
Exactly.
Okay.
Boom.
Cool. So I wouldn't expect this to do the right thing, since we need to. The tree here. We have to iterate across it as well as we go.
Yeah. Can we just see something like this?
Ooh.
Wouldn't
That's a good idea.
Be sorry. Is it like this? I can't remember.
It seems reasonable. There's a spelling mistake right here. All right, I hit it.
Frump. Yeah. Okay. Now it's at least a bit prettier.
Yeah. Okay. So we're definitely inserting vowels, so that's good, and we seem to be finding like. Here we go again. Uh-oh. What'd you do?
I didn't touch
Nothing
it.
different.
Yeah.
Oh, okay.
I guess it's just a delay somewhere. So the link
okay.
probably contain this empty default dict, right? Since we put them everywhere.
Yeah. Okay, so it's 2:46. We should probably break here and wait for more questions.
Yeah.
But I do look forward to solving this problem. Yeah. Okay. So
maybe
it's a bit of a demo.
maybe the viewers can be the navigators for a bit. I'm sure they have solutions already. Okay.
Okay. I guess I'll stop my screen share, and if anyone has a question about anything really, I'll give you a chance to ask or discuss. Oh, there's lots of chat questions. Oh, no.
Maybe they were mostly relevant for the first problem. Did anyone solve Advent of Code last year? All of the problems? Perhaps. Well, that was pretty much our demo, just to highlight a bit what it is like being the navigator and the driver in a pairing session. And in the end, it's mostly up to you and your pairing partner to determine the flow of your working style together. There are no clear definitions of how to best do this. I guess it's mostly about the practice, like Winnie mentioned before in the introduction to, it takes some skill to develop an effective pairing technique.
Yeah, I mean, I was hoping to do a lot of pairing in academia, and I guess I could talk about that a bit more. That what I found is that in a purely an academic environment where everyone has to get credit for what they do, it's actually really difficult to really get credit when you're pairing. And I've been burned a few times actually by that. So yeah, I can't recommend it in an academic environment. But if you are in an environment where the team output makes sense, then I think pairing becomes very interesting and a lot of fun. Also, it's tiring, so take lots of breaks as well.
I think that thing about credit that you mentioned happens a lot in the open source community, of course. But I believe that, pair programming is very common also within open source projects. We work on open source projects in MBase ourselves, and we practice it a lot. Mostly, we don't do application sharing, but we mostly do screen sharing. And it's, personally, I'm super happy, and we haven't really had too many issues when it comes to credits. So I encourage you guys. It was really good presentation and really great technique.
Great, thanks.
Yeah, thanks.
Does anyone else have any questions for our speakers today? I think that was really cool. It was a very useful demonstration, and I really like how you highlighted that that you start thinking collaboratively when you start engaging in pair programming. I think that's a very useful point, and we could definitely do better with that in academia as well.
Yeah.
Well, if you don't have any more questions, if no one has any questions now, I'll be putting this video on YouTube, and you can of course continue the discussion